So permutations are possible arrangements of objects. And I want you to keep this word arrangements in mind because this is what helps us distinguish a permutation from a combination, which we're going to talk about next. And so if you think about, you have 3 letters, A, B, and C, and you want to arrange them, then there are 6 possible arrangements. You could do ABC, you could do ACB, you could do BAC, you can do BCA, and you can do CAB and CBA. Now, we knew how to compute this before. You have 3 letters, and you're trying to order them. So you have 3 choices for the first letter, and 2 choices for the second letter, and 1 choice for the third letter, or 6 possible choices. It turns out this is the same as 3 factorial, 3 times 2 times 1. So the number of ways to arrange or permute n objects is n factorial, which is n times n minus 1 times n minus 2, all the way down to 2 times 1. Now, what I want you to think about is what happens if you don't need to use all the letters. Like, what if you have the letters A through F, and you're going to make arrangements of 4 letters. So if you think about it, you have A, B, C, D, E, F, 6 letters to choose, and you're going to choose 4 of them. So you have 6 choices for your first one, 5 choices for your second letter, 4 for your third, and 3 for your last letter. So this feels a lot like the permutation before. This is an R permutation. Of n objects. And the notation that we use is P of n comma R. And it starts with n factorial, but then we divide out n minus R factorial. Because what you see is in the example we did P of 6, choose 4. So we did 6 factorial divided by 2 factorial, because notice the 2 and the 1 at the end here were missing. We took away that 2 factorial because we only want to do the first R objects. So this is the way to compute a permutation. In Desmos, there's a button for this, so you can use that as well. Let's do a couple of examples. The final night of the Folklore Festival will feature 3 different bands, and there are 7 bands to choose from. How many different programs are possible? So if we put Green Day first, or we put Green Day last, this is a different concert, right? I mean, they're probably not playing at the Folklore Festival, but understand that a program means that the order we arrange the bands matters. So this is going to be a permutation. And our n is going to be 7, because that's how many we have to choose from. And r is going to be 3, because that's how many we want to select. So we're going to do P of 7, comma 3. Now, you could have done this before just using the multiplication principle. You have 3 slots to fill. You have 7 choices for the first, 6 for the second, and 5 for the third. If you want to use the permutation formula, especially when the numbers get larger, it's 7 factorial over 7 minus 3, or 4 factorial. So let me go to Desmos so I can show you that in Desmos. If you hit the Functions button and then you scroll to the bottom, it has this NPR, which is permutations. We had permutations of 7 objects, choosing 3 of them. So we get 210. So there are 210 possible programs. Okay, one more example. There are 5 varieties of roses and 2 varieties of tulips to be arranged in a row for a photograph. In how many ways can they be arranged if both varieties of tulips are placed together, and then again if no varieties of tulips are placed together? So what we're going to do is we're going to arrange all 7. And in some of those arrangements, the tulips are going to be together, and in other arrangements, they're not going to be together, right? So if we find the total number of arrangements, this would be P of 7, 7, which is 7 factorial. (5,040) possible arrangements. Now remember, in some of these arrangements, the 2 varieties of tulips are together, and in the others, they aren't. So if we want to find out that the 2 tulips go together, what you can imagine is that you have this block with the 2 varieties of tulips inside of it, okay? So you have this block, and the 2 varieties of tulips are inside of it. So what you want to do is arrange the 2 varieties of tulips. So that's P of 2, 2, which is just 2 arrangements, right? And then what you think about is you have the other 5 roses plus the block of tulips. So you're going to arrange the 6 blocks, which is the 5 roses plus the tulips, then arrange the tulips. And remember, then is kind of like the word and, right? So we're going to arrange the first 6, 6, 6, and when we say that word and, we multiply in counting problems, and then we're going to arrange the tulips. So this is 6 factorial times 2 factorial. $720 times 2. So this is 1,440. And these are arrangements where the tulips are together. In the other case, this is number 1. In the other case, number 2, remember there are 5,040 total minus the 1,440 where the tulips are together. Leaves me with 5,040 minus 1,440, 3,600 arrangements where the tulips are not together.